And welcome back to 5.1. Let's continue with another example of substitution. So here we go over here. Now when you look at this, you need to detect that this is a good candidate for substitution. And the reason is because even though we don't have a variable by itself, we have a variable that would be very easy to get by itself. Do you see which variable that is? In one step, we can get it by itself. It's the 2y right here. If we divide by 2, we're going to have y by itself, and then we're ready to do substitution. So let's divide this equation, the top one, by 2. And remember, when you divide, you need to do that to every single term in the equation because of the distributive property. So that cancels, and so let's write our updated equation over here. It's going to be y equals 4x plus 5. And just like that, we have a y by itself. So let's grab this 4x plus 5, and we're going to plug it in for the y right there. And make sure you plug it in for y. It's important that you plug it in for the variable that it corresponds to. So here we go. 3 times 4x plus 5 plus 3x equals 135. I mean, here I guess you could plug it in for either one because it's 3 and 3, but get in the habit of always plugging it in for the variable that you've solved for, or else you're going to make lots of mistakes. Notice again, I have this in parentheses because it's 3 times all of 4x plus 5. Distributing gives us 12x plus 15 plus 3x equals 135. Now it's just solving the equation. Add 12x and 3x together gives us 15x plus 15 equals 135. Minus 15 minus 15. Trying to get x by itself. 15x equals 120. And then divide by 15, divide by 15. X equals, well, if you double 15, you get 30. And 30 goes into 124 times, so therefore 120 divided by 15 equals 8. And just to be sure, 8. All right, so x equals 8. And now you can take this variable, and once you have a variable solved, you've kind of unlocked the door. So we could plug it into this one or this one. I'm going to plug it into this equation because this one had y equals, so that would make life really easy. Instead of writing x, I'm going to write the number we've solved for. So y equals 4 times 8 plus 5, so y equals 32 plus 5, y equals 37. This is the only point, 8, 37. This is the only point that's going to be the solution for this system. So there you go, x equals 8, y equals 37, and like the other one, this solution is also, this system is also going to be consistent and independent because we were able to find one solution. If you're on a test, the way you check yourself so that you know you got the exact right answer is to take these two values and make sure that they satisfy both equations. If you plug them into both equations and it satisfies both of them, then you know you're right. So maybe we'll do that on a problem where they're easier to check. But you should take the time to do that when taking a test. Let's look at the second way of solving these besides substitution, and this is the method of elimination. And as you can tell, this is my favorite method of solving equations because it's quick, it's easy. Well, I think it's not that bad. And you get to eliminate a variable. So let's take a look at how it works. The way you can tell that you can use elimination is that your variables all line up. So do you see how the x's line up, the y's line up, and the numbers line up? That makes us a good candidate for elimination. So what you want to do is you need to make it so that two of the variables, one like the y and the y, you need to make it so that they have opposite signs. And so we see that these two already have opposite signs. Then you need to make it so that they have the same number, the same coefficient in front. And so we see how that's a 3 and that's a 6. Here's what I'm going to do. I'm going to multiply the top equation by 2. Because do you see how that's going to make this be a negative 6? So then what I do is I write 2 little arrows off to the side. Okay, because we've updated one of the equations. The bottom equation has stayed the same. Okay, so there's the bottom equation. It's fine. The top equation, when we do distributive property, will be 2x. 2 times negative 3y is negative 6y. And this is a common mistake. Don't forget to also multiply the last number. I see scholars miss that one a lot. So these are our two new equations. The bottom one stayed the same. The top one we just multiplied by 2. And now do you see how it's negative and positive and the two coefficients are the same? Watch this next step. It's this easy. I'm going to do something we've never done before. I'm going to add the entire two equations together. Isn't that cool? I'm just going to add them together and watch what happens. 2x plus 4x is 6x. The 6y cancels the negative 6y, which is what we wanted. And 4 plus 26 is 30. And now we have 6x equals 30, and we're one step away from seeing what x is. Isn't that just great? I love that. It's just so wonderful. It's just a simple multiplication. Add the equations together, and then you're there. No tricky substitution with a whole bunch of extra work. Divide by 6, x equals 5. So we have our first x variable, and now you can go back and you can plug it into either equation to solve for y. So I'm going to plug it into the bottom equation. 4 times 5 plus 6y equals 26. 4 times 5 is 20, so 20 plus 6y equals 26. Minus 20 minus 20. Sorry if I'm going too fast. If this is too fast, just rewatch this part, but hopefully you're pretty quick at solving equations. Divide by 6, y equals 1. So the answer is x is 5, y is 1, or 5, 1. Remember, this isn't an interval. This is the point 5, 1. So I know that can get a little confusing. Let's go ahead and check this one. Let's plug in a 5 here and a 1 for y and see if it's true. 5 minus 3 times 1. Well, 3 times 1 is 3. 5 minus 3 is 2. So we work on our first equation. And again, that's ignoring the 2 right there, just the original equation. How about plugging in 5 and 1 here? Well, 4 times 5 is 20. 6 times 1 is 6. 20 plus 6 is 26. So we've checked both equations, and so that's how we know that our answer is correct. So we get a smiley face because we know that that's the right answer. Let's do one more elimination problem. All right. Looking at this, it seems that I can eliminate the x's really easily. They already have opposite signs. And the reason opposite signs is important is because if the signs are the same, they just get added together. We need the signs to be opposite so that they cancel. So like in the previous one, let's multiply the top equation by 2 and see what we get. Oh, okay. So that'll be 4x plus 6y equals 16 when you multiply the top equation by 2. Bottom equation stayed the same. Negative 4x minus 6y equals 12. All right, we're now ready to do the elimination step. So we're actually going to add the two equations together. 4x and negative 4x cancel and go away. But this is interesting. Look, 6y and negative 6y also cancel. And so on the left side, I don't have anything left, so it's just 0. And on the right side, 16 plus 12 is 28. So I have 0 is equal to 28. Is that true? No, it's never true. And so that means there's no values of x and y that'll work. There's no value of x and y that can make 0 become 28. So there's no solution. And do you remember what we call that? What type of system this is? From our previous page of notes, we see that this is an inconsistent and independent system. So this one is inconsistent because there's no solution, but the lines are still different from each other. The equations are different. They're not just a scalar multiple of each other. So they're inconsistent and independent. This one, remember, was consistent and independent. All right, so there we go. That's how to do elimination. And it's kind of interesting that there's no values of x or y that'll make both of these be true. In the next part, we'll do 2 more examples and then start to take a look at how to solve systems of equations that have 3 equations and 3 variables. So I will see you in part 3.